So in this video, let us discuss about the mirror formula for a concave mirror. That is, if first we want to find the mirror equation when a real image is formed on a concave mirror. Suppose we have a concave mirror like this. Let this point be the pole of the concave mirror, and this C represents the center of curvature of this mirror. Suppose I place an object, let's say AB, beyond the point C. We have the theorem, that is a light ray passing parallel to the principal axis. This is the principal axis. The line passing through C and P, this is the point P, okay. The line passing through C and P is the principal axis. Suppose if a ray is drawn parallel to the principal axis like this, after reflection on the mirror, it passes through this point. We can call that as focus. So every ray which is passing parallel to the principal axis after reflection passes through the focus. And we need one more ray so that the intersection gives the image. We can take another ray through the center of curvature. That is, any ray passing through the center of curvature after reflection, that is at this point, retraces the same path. Clear? So an image is formed here. We can call that as, let's say, A dash B dash. And so this is the object AB and this is the image. Now we need to find the mirror formula. Here the real image is formed because actually the mirror, the rays after reflection meet at this point. This point is actually B dash, okay. Now we need to mark certain distances. That is, we usually call the distance, all the measurements are taken from the pole, okay. So the distance of the object from the pole is this one, we call as U. U is the object distance. Object distance. And clearly the image is formed here. So the distance of the image from the pole is called the image distance V. V is the image distance. Now this distance of the pole from the focus, this is the principal focus, is the focal length F. So F represents the focal length. Here the focal length of the concave mirror. Now we need to consider the property of the similar triangles to derive the equation. For that, first let's consider triangle ABC and triangle A dash C dash B dash. That is, consider triangle ABC and triangle, that is ABC and A dash B dash C dash. C dash. Let me draw that triangle here. This triangle, this is A, B, this point is C, this is A dash, B dash. Clear? Clearly these angles are equal. And this forms 90 degree. So these two triangles are similar. So that I can write the side opposite this angle is AB. AB divided by the angle opposite to this angle is this one, and the side opposite to this angle is A dash B dash. A dash B dash equal to, also when these two angles are equal, definitely this angle will also be equal. So the side opposite to this angle is AC. The angle equal to this angle is this one. So the side opposite to this angle is A dash C. Clear? Let me call this as equation number 1. So from these two triangles we get this relation. Now again, if I drop a perpendicular from here, let's call that as ABCDE. Here the point, this point is P, the P here, P, pole itself. This EP is approximately 0. I can say that E and P almost coincide, but since there is a curvature in here, I cannot write this E and P as the same, but this EP is almost equal to 0. So that FE, let's say this point FEG, that is FEG form a triangle. Now let's consider triangle B dash A dash F, B dash A dash F, and this triangle FEG. Let me draw that here. This point is G, this point is E, this point is F, this point is A dash B dash. Again, these two angles are equal, that will form the vertically opposite angles. This angle is 90 degree. Also the third angle will be same. Clear? Now if we take the ratio of similar triangles here, we can write A dash B dash by, or let me write EG first. That is the angle, the side opposite to this angle is EG, divided by the angle equal to this angle is this one. So the side opposite to this angle is A dash B dash, equal to angle opposite, side opposite to this angle is FE, and this angle is equal to this angle, and the side opposite to this angle is A dash F. So that let me rewrite this EG. When you look at the figure, this AB and EG remains the same because they are between the same parallels. So I can replace this EG with AB. So AB by A dash B dash will be equal to FE. This replace this EG with AB. A by A dash B dash is equal to FE by A dash F. Call this as equation number 2. Now, if you compare equation 1 and 2, on the left hand side, both is AB by A dash B dash. So I can equate the right hand side. So you will get AC by A dash C equals to FE divided by A dash F. Clear? Now we have to put the U, F and V, or all those values in here. Before that, this AC is actually, AC can be written as AE or AP. Here AE is actually AP, okay, because in our consideration EP is 0. Okay, so this AC will be AP minus CP, right? So this AC equal to AP minus CP. Now A dash C dash, this length is actually CP minus A dash B. Clear? CP minus A dash B. That is, this A dash C is equal to CP minus A dash B. Now let's come to this FE. FE is equal to, you don't have to write anything, just put FE, or I can write in FE or FP by A dash F is actually A dash F, this one, I can write A dash F as A dash P minus FP. Clear? This length A dash F is equal to A dash P minus FP. Now, we have to consider the Cartesian system, that is, the light is actually moving in this way. Okay. And all the measurements are taken from the pole. That is, from the pole, it is in this direction. So, everything opposite to the direction of the light, we have to take that as negative. Or everything to the left of P, we have to put the negative sign. Anything to the right of P, you can consider that as positive. So, AP, here AP is our U, but I have to put minus U because it is on the left of P, minus CP. Here CP is actually the distance between the C and P is the, let me mark it here, CP. That is, CP is actually the radius of curvature. But we know the relation between radius of curvature and focal length as R equal to 2F. So, CP is actually 2F. We already derived this relation, that is relationship between radius of curvature and focal length. And if you have any doubt, you can always go back and check the video. So, CP, I can put CP as 2F. And also, the F is on the left hand side, so I have to write minus 2F divided by, or the focal length of a concave mirror is always negative. Okay. Or its radius of curvature is also negative. Now CP is equal to minus 2F minus A dash P is equal to V. But here also you have to write the minus V. Now FP is the focal length, that is minus F, that is also on the left hand side. A dash P, that is minus V, minus FP is again minus F. Clear? So simplifying this, you will get U plus 2F divided by minus 2F plus V is equal to minus F divided by minus V plus F. Okay. Now, if you multiply, that is minus U, cross multiply U plus 2F into, I can write this as F minus V. This is equal to minus F into F minus V also, equal to minus 2F plus V times minus F. Clear? So, minus U into F is minus UF, minus U into minus V equal to UV, plus 2F into F is 2F square, minus 2F into V is minus 2FV. Here it will be minus 2F into F is 2F square, minus and minus will get cancelled, and V into minus F is minus VF. Clear? Clearly you can cancel this 2F square and 2F square, and rearranging you will get minus UF. Let's take the VF to the left, minus plus VF is equal to plus VF. There is also a minus 2F here, minus 2FV equal to, take the UV to the right, so it will be minus UV. Clear? I just took the VF to the left hand side and UV to the right hand side. Now VF minus 2FV is minus UF minus VF equal to, this will make it minus VF equal to minus UV. Cancel with, you can cancel all the negatives, so that UF plus VF is equal to UV, and if you take F as common, it will be u plus v equal to uv. Now we have f is equal to uv divided by u plus v. Now if you take the reciprocal on both sides, you will get 1 by f equal to u plus v divided by uv, taking the reciprocal on both sides. So this is equal to 1 by f equal to u divided by uv, divide each term with uv, plus v divided by uv. So that 1 by f equal to, can cancel this u, so it will be 1 by v plus, cancel this v, 1 by v plus 1 by u. So this is the mirror formula of a concave mirror when a real image is formed. See, it does not depend on whether the image is real or virtual. The mirror equation is always 1 by f is equal to 1 by v plus 1 by u. And in the next video, we can derive the same formula for the concave mirror when a virtual image is formed. Clear?